Okay, questions on the homework other than what we just got quizzed on from test 5. Or, never mind, we'll go over the quiz first because I'm getting the last one right now. So, on our first one, I do have all of them, correct? Going once, going twice? Alright, the first one gives us info about what houses have a pool, what houses have a hot tub, what houses have both or neither. That should scream Venn diagram. In Venn diagrams, we always fill from the middle out. So, the 23% that have both is going to go in the middle. And then if 35% of the houses have a pool, your pool circle needs to have a total of 35. 23 of those are already accounted for, so the rest is 12. Okay, so then the question is, we don't have enough information to get the just hot tub category. We used our 2 pieces of information we've already filled in. So, unfortunately, we don't have the rest to fill it in, but given the question, we don't need it. They want the probability that a house has a hot tub, probability of having a hot tub, given that it has a pool. If you're given that you have a pool, just like in a chart, we would limit ourselves to just looking at the pool column or the pool row. If it's in a Venn diagram, we limit ourselves to just looking at the pool circle, which is out of 38. And how many of those also have a hot tub? That's your 23 out of 38. Thank you. Was it 38 on the homework? I'm thinking that's why I did that. So 23 out of 35. One quick thing here. And I don't know how particular the Regents is going to be on this, but I will say this. If it asks for the probability is usually a decimal or a fraction. Okay? So you could leave it like this as your probability, or you could do that. It didn't say to the nearest percent or anything, so it didn't ask you to convert to a percent. If you did, I'm not going to count you off for it. It should be 65.71%, and I also didn't tell you what to round to. So if you put 65.7, I'm fine. If you put 66, I'm fine. As long as whatever you rounded to correctly. But keep in mind, probability is technically fraction or decimal. Unless they want the answer in a percent, maybe you don't change it, just in case. Okay? On the next one, we have a polynomial. We're missing a C value. But they're telling us x minus 1 is a factor. So this is the remainder theorem. If x minus 1 is a factor, then when you plug in 1, you should get 0. So I'm going to go over here, and I'm going to plug in an x of 1, and it should give me 0. So I do that. I plug in a 1, and it should give me 0, and I'm going to solve for the C accordingly to make that happen. So this term is 2, this term is 4, this term is 5. It ends up being C plus 11, and C equals negative 11. Did I do something wrong? No? Cole, you look like you're checking my work. Okay. Okay. And then the very last one here, this one was a little bit tricky, I thought, just because kind of wrapping your head around what was happening. Here's a ball that's just bouncing. It's dropped from a height of 20, and then it bounces, and it only reaches 80% of its previous height. Well, 80% of 20 is 16. And then 80% of 16, 0.8 times 16, would tell you that the next height is 12.8. Could you do this the whole time up until the 6th bounce? You could. However, when you're consistently decreasing by the same factor of 0.8, multiply by 0.8, multiply by 0.8, multiply by 0.8, it's a geometric sequence. And if this is the first term, then the second, the third, the fourth, the fifth, the sixth, technically we want the 7th. After the 6th bounce, how high does the ball bounce after its 6th bounce? So if that's your first term, second, third, fourth, fifth, sixth, 7th, we would want a sub 7, which is your first term is 20. The ratio, the constant multiplier that we have here is 0.8. And then to the 7 minus 1 power, and we just type that in. Now that one was a little tricky. If you happen to put the 6 power because you saw 6 bounce, You kind of can see now how that's, you could still get it if you use 16 as your first bounce, right? If you did use 16 as your first term and then you were looking for A sub 6, you would still get it. So there will be partial credit. That was kind of a tricky part, but this ends up giving us 5.24288 to the nearest tenth of a foot, 5.2 feet. Okie doke. Now, yes, again, we could have done this out manually, but what if they asked after the 50th bounce? They're going to ask you on the Regents a high number, I would assume, so that they force you to use your equation. And remember, this equation is on your reference sheet. You just have to realize that it's a sequence as opposed to the series. Sequence is when you're just looking for the term. Series is when you're adding everything up. They just wanted the sixth term. So it was just a sequence, and it was geometric because there was a constant multiplier. Arithmetic is when there's a constant difference. Like it's 3 less every time, and you're just subtracting 3, subtracting 3, subtracting 3. That's arithmetic. Okay? Questions on the homework? No? Cole, go ahead. What? 18. This was test 5, right? Okay, the Smiths have 4 children. Here's the way I suggest you do this. What is the probability that they have 2 boys and 2 girls in any order? And that's kind of the trick here, is that it's in any order. It is small enough. I would say just kind of do a tree diagram.
The answer sheet, what does Florida State tell me?
Okay, so, yeah, this one, 4C2 is something we didn't do this year, so I'm going to not use that.
Why do you put it there?
I used last year's answer key, I'm sorry. So I didn't want to redo the whole answer key for the one problem. So I am going to show you just a different way, and that's just a basic tree diagram. So your first child is either a girl or a boy. Your second child is either a girl or a boy if you have a girl, or a girl or a boy if you have a boy. Your third child, every kind of tier is a child. So first child, second child, third child, girl, boy, girl, boy, girl, boy, girl, boy, and then your fourth child. Every one of these has the girl, boy option coming off of it. So not overly efficient, but given the way I, have recently, think the curriculum is going a certain direction, I think this is the best way. So now, we have how many different combinations? We have girl, 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 boy, girl, girl, boy, girl, and so on and so forth. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total ways that this whole thing can pan out. How many have exactly 2 girls, 2 boys? Well, girl, 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 girl does not count. Girl, 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 boy. This whole girl, girl, girl category doesn't count because you already have 3 girls. But I could do girl, girl, boy, boy. That's 2 of each, right? I can do girl, boy, girl, boy. That'll count. Girl, boy, girl, boy. I can also do girl, boy, boy, girl. So there's 3 over here on this half. And then I'm going to do the same thing on this tree, and I'm going to probably find 3 more. So there's 6 total, and 6 out of 16 gives me the percentage chance. I don't think that's going to be on your Regents. That's not the what probability, if I told you over and over again, is probably going to be on your Regents? Given probability of like the pool hot tub, this given that, either from a chart or Venn diagram, and independent events. Okay, those are that's where I think they'll stop with probability. They could surprise me, but I think those are the main 2 that keep getting tested over and over again. Other questions on the homework? Okay, oh yeah, go ahead, Cole. 29 is a tricky one. At the age of 15, Sarah got a weekly allowance of 35, and she also made $13.75 an hour where she worked 20 hours. So at 15, in a week, she made 35 plus $13.75 times 20 hours. Okay? Now, as each year goes on, her parents are raising her allowance by $5. So this is increasing linearly. If you add 5 every year. So this is what her allowance is doing after X years. Her job, on the other hand, her raise is by a certain percentage. So that is like a geometric or an exponential growth type of problem, where each year her 13.75 is being multiplied by 1.04. To increase by 4%, you multiply by 1.04 to the x power. So you're doing that every year, multiplying by 1.04, multiplying by 1.04, and that's giving you her new hourly rate, and she's always seeming to work 20 hours. So that's still times 20 is there, but this 1375 is increasing exponentially. When you're increasing by a percent, it's exponentially. When you're increasing linearly, it's just mx plus b. Okay? All right. Pass your homework forward. We'll do our flashcard quizzes. Thank you. Here is number 1. Here's number 2. Here's number 3. Here's number 4. Here's number 5. And here's number 6. Okay, pass those forward. Okay, in an even function, not an even degree, okay? Even degree talks about polynomials only, talks about end behavior. But any function can just be plain old even, which means it's symmetrical to the y-axis. Or you could say this, f of negative x equals f of x, because that's the algebraic test. You plug in a negative x, and if you get back the original, it's an even. X to the a times x to the b, what do you do with those exponents? Add them, okay? Compound interest formula, okay? There are some people that are confusing that with like the regular growth decay formula, but the growth decay formula goes to the t over p power, and this one goes to the n times t power. You didn't need to write all these, but your rate gets divided into n parts depending on how many times you're compounding and so forth. Okay? Not to be confused with this equation, the 1 plus or minus r to the t over p. That's basic exponential growth decay. This is particularly for finance and for compounding interest. And the PERT one is continuously compounded. The PERT one, I think, did that come up yesterday here? Yeah. This one, just know that that's your denominator, so this is x to the a over b power. Independent events. Okay, I don't care what you call your events, what letters you use, but your probability of event A has to equal the probability of event A again, but given B the second time. Okay, and if events are independent, this will equal each other. And then the point on the unit circle. Okay, when you have a point on the unit circle, the x-coordinate is the cosine of your theta, and the y-coordinate is sine. Some people switch those by accident a lot and do sine and cosine, and I always just remember that sine and y sort of rhyme. So the sine is the y-coordinate. I don't know if that can help any of you. But meaning, if someone told you that this was a 30-degree angle, and they said, okay, this is a 30-degree angle, what's this point? All you have to do is take the cosine of 30, which is root 3 over 2, and the sine of 30, which is 1/2, and you have your point. Okay? All right, so take out your separate sheet of paper for a couple, some practice problems. Good, we got a lot of time today. A lot more time than we seem to have been having, so we should get through test 5 today, meaning the ones that you didn't do. We did 21 yesterday, is that true? Did we do 22? We did? Oh. We did not do 23. So I want you to take a minute and read 23 and try it on your own and see kind of what we, I'll give you the whole paragraph, what we end up with here. Hold on, I'm going to get it to a spot where it's all can be read. Can you read everything there? There. Cole Taylor, 6 out of 6. Nice job. You did? You finished it? Come here. Tell me which one you think it is. Don't tell anybody. Not that kind of question.
Oh, okay.
This is us.
Yeah, I see that.
Okay, you got the same deviation, and you probably never occurred. That's not one too yet. Okay, go. All right, hold up 1, 2, 3, or 4. Hold up a fist if you don't know, if you're gonna. Right, like don't look around at everybody else. Just hold up a fist if you don't know so that I know. All right. Cole, in like one quick phrase, what kind of question is this? Norm CDS. If you're asked for the area or the probability of something happening under a normal curve, with a normal distribution, it's norm CDS. So we are given our mean of 1050, our standard deviation of $1.25, and they're asked what is the percentage between 8 and 1175. So you would do norm CDF, your minimum is 8, your maximum is 1175, comma, your mean is 1050, and your standard deviation is 125. Okay? You did not really have to use this curve, correct? Okay? But I will say this. This is done based on Z-scores. Okay? So we should touch on Z-scores in case they somehow phrase it and they force you to come up with a Z-score. 8 has a Z-score. The Z-score is how many standard deviations it is away from the mean. Okay, so if your mean is 1050, and we're trying to find a Z-score for 8, how far away from 1050 is 8? How much money away is it? 250. But each standard deviation is 125. So how many times is 125? How many standard deviations are in 250? 2. So this is 2 standard deviations below, so it would be a Z-score of -2. And so that would be here, okay? Now there's a formula for that. It's the score minus the average divided by the standard deviation. That's what is on a flashcard that you have to remember. So the score was 8, minus the average was 1050, over $1.25 is the standard deviation. That's -250 over $1.25, and there's your Z-score of -2. Because it was a nice whole number, we could kind of figure it out on our own, okay? And then with the 1175, that is, again, the Z-score for that would be the score minus the average. So essentially this is you figuring out how far away from the average it is, and it's $1.25, divided by your standard deviation, which is $1.25, so it's exactly 1 standard deviation above. So if on some weird problem in an open response they force you to use this diagram and to explain, and then you would have to change it to Z-scores and say, so the $8 has a Z-score of -2, and the 1175 has a Z-score of 1, and if you add up all the probabilities in between, you get 82%. But being most efficient about it, for us, with a multiple choice, norm CDF. Got it? Okay? And so the next one, 24. Definitely need a separate sheet of paper for this one, so take a minute on 24. And try to find the equation of the parabola with a focus and a directrix given. I don't know how many more times we could do this, or how much I can tell you this is going to be on your region. If you haven't drawn a picture by now, shame on you. You need to sketch a picture of what's going on for these. I would never start without drawing a picture to wrap my head around it, so certainly you should not. Tyler, 6 out of 6. Nice job on your flashcards.
What did I do?
I'm not there yet. Do you want me to say it out loud when I get to it?
Yeah.
No?
Yeah?
Oh, yes, okay. Five and a half out of 6, Jake. Do you know what you did wrong?
What did I do wrong?
You had your cosine sine flipped. You had sine cosine, it's cosine sine. Sine is your y.
But that's still pretty good, right?
Yeah, that's very good. Oh, shoot, actually. Okay, let's see where we are. Here's my focus at 2, 4. Here's my directrix at -2. The vertex is always halfway in between, yes? So, there are 6 units between these two, so I gotta go up 3 units, and my vertex should be halfway in between. By the way, sometimes they'll give you the vertex and the directrix, and you have to go the other way for your focus. Or sometimes they'll give you your focus and your vertex, and you have to go your other way to get the directrix, but know that the vertex has to be in the middle, okay? So right now, we can already tell that our vertex is 2, 1. And based on the fact that we know this general formula of a parabola, HK is 2, 1. The problem is options 1, 2, and 3 all have a vertex of 2, 1, 2, 1, 2, 1. The only one we can eliminate from just that piece of information is 4. Okay? Then from there, we got to find out what's the A value. Is it 1/12, 1/4, or 1? How do you know? So you have to go with, again, what the flashcard says is that P to F distance has to equal P to D. Well, you got to get a point on your parabola. So if I pick a point here, call that XY, I need to do a distance formula from my point to focus, and I need to do a distance formula from my point to directrix. Now this point has to be x comma -2. So now it's a distance formula on your left side of the equation equals the distance formula on the right. So point to focus first. One thing I will say is these have been coming up. I have people doing 2 minus x, which isn't wrong. It's just not as easy to square that, I don't think. So if you can, do your point to focus, point to directrix. So x minus 2 squared plus y minus 4 squared. And then point to directrix would be x minus x squared and y plus y minus -2, which will be y plus 2 squared. And always your square roots on both sides are going to cancel. Always you're going to have something minus something giving you 0. That's the x minus x here. And you'll have 3 variables left, 2 of which are the same, and those are the 2 that you square out. That's the y minus 4 squared and the y plus 2 squared. The x minus 2 squared, I'm leaving alone, because that's my h for HK. H was 2. I am going to square this out. I get y squared minus 8y plus 16 on the left equals y squared plus 4y plus 4 on the right. What should always happen now? The y squareds will cancel. And then I just have to rearrange and get all my y's together, away from the parentheses. So I'm going to add this 8y over. And that's going to give me x minus 2 squared plus 16 equals 12y plus 4. Get y all by itself. Subtract that 4 over. And then divide everything by 12. Now on the parentheses, that's going to turn into, there's a 1 technically out in front of the parentheses already. 1 divided by 12 is 1/12. That's my A value. Then I have the x minus 2 squared, that's my h, and 12 divided by 12 gives me a 1 as my k. So HK, of course, is 2, 1. We knew that it should be. And the A value we found is 1/12. I'll die if that's not on your Regents. I'm almost positive. It's been on every single one. Okay? And it's been tricky in some cases where, like I just told you, they'll give you the focus and the vertex and you have to come up with your own directrix. Just by counting 3 units away, 3 more units away, or the vice versa of that. And then once you have those 3 pieces of information in the right spot, then this is all the same old, over and over again. Okay? All right. Jumping to 32. This is more of an explanation type question. You got a spinner game. What is the probability that Keith spins and he lands on an odd number, and then Julie spins and lands on a multiple of 4? So that's and probability. And means what operation? And means multiply. Or means addition. Okay? And is multiply. So the probability that Keith spins and lands on an odd number is 6 out of 12, yes? Times, and here's Julie spinning and landing on a multiple of 4. The multiples of 4 are 4, 8, and 12, so that's 3 out of 12. So that would be 18 out of 144, which probability as a decimal would be 0.125. So there's part A. Are these independent events? This isn't so much the check of independence that we're used to. This is a more generic thing. When you spin the spinner the second time, is it affected at all by what happened the first time you spun? No. So they're totally independent of each other. Versus if you're picking cards from a deck and you pick the first card and you leave it out of the deck and then you pick the second card, those are dependent because you've changed the pool of cards that you're choosing from. All right, and the last question here from this test. Solve this quadratic by the quadratic formula and by completing the square. Okay? I'm going to trust that we all know that to do the quadratic formula, we need to add the 6x over and just plug into the formula. And then I'm not as confident that we know how to complete the square perfectly well. So we may, I think we'll just pick up with this in class, complete the square in class tomorrow. So we are done with test 6 except for this question, or test 5, your homework tonight, test 6, 1 through 10, and so on. You know the numbers. Goodbye. Have a good day. Don't do anything I wouldn't do.